neuron, histaminergic neuron. Similarly, we have got serotogenic neuron. Serotogenic neuron means synthesis, storage, and release of serotonin takes place in such a neuron. And the main area exactly where the synthesis, storage, and release of serotonin takes place is the nerve ending of the neuron. So we'll zoom up this nerve ending and we'll check what all steps are involved in the synthesis and then storage and release of serotonin. So this is a nerve ending of serotogenic neuron. So for the synthesis of serotonin, we require an amino acid, and that amino acid is nothing but tryptophan. So tryptophan moves inside this nerve ending. This is the structure of tryptophan. Okay, so this is the structure of tryptophan, and just compare it with serotonin. So serotonin and tryptophan structures are almost similar except two differences. First difference is on the fifth position we need to add OH group, and second difference is we need to remove this COOH. Okay, so from the tryptophan, if you add OH group and remove COOH, then it will look similar to that of serotonin, and accordingly we should plan the synthesis. Means not we should plan, but already it has been planned inside our body. So just two changes, one OH group you need to add and one COOH you need to remove, and accordingly the synthesis also take place. Okay, so tryptophan moves inside the serotogenic nerve ending, and in the nerve ending it meets with an enzyme, and this enzyme is nothing but hydroxylase. So what do we expect what this hydroxylase will do? Yes, to this tryptophan on the fifth position it will add OH group, and this was what we want. So now tryptophan is converted into 5-hydroxytryptophan. Okay, same tryptophan, but at the fifth position there is hydroxyl group, so we call it as 5-hydroxytryptophan. Similarly, in the nerve ending also tryptophan gets converted into 5-hydroxytryptophan. Next, this 5-hydroxytryptophan it meets with another enzyme, red color enzyme. And what is this red colored enzyme? This is nothing but decarboxylase, and this is also what we wanted. So what is decarboxylase will do? It will cause removal of CO2, so that 5-hydroxytryptophan finally gets converted into 5-hydroxytryptamine. So this is nothing but your serotonin. Okay, so for the synthesis of serotonin we want two enzymes, and it is a two-step process. Firstly, initially what happens, tryptophan moves inside into the nerve ending of the serotonin, and it meets with an enzyme hydroxylase, and then this hydroxylase will convert tryptophan into 5-hydroxytryptophan. Next, this 5-hydroxytryptophan meets with another enzyme, that is the decarboxylase, and this decarboxylase will remove COO, so that 5-hydroxytryptophan is get converted into 5-hydroxytryptamine. So this is about the synthesis of 5-hydroxytryptamine. But our work is not completed yet. We have synthesized. Our another step should be storage. You know why storage is so much important? Because in the nerve ending there is an enzyme. The name of this enzyme is MAO, that is monoamino oxidase enzyme. And what this enzyme will do? It will destroy 5-hydroxytryptamine. We'll check out what happened. So this monoamino oxidase, the name only says monoamino oxidase, it will cause oxidation of the monoamine, and it remove the amino group, it destroy the amino group, and because of which this 5-hydroxytryptamine will convert it into a compound 5-hydroxyindole acetic acid. But we do not want 5-hydroxyindole acetic acid, we want 5-hydroxytryptamine. Okay, so in this destruction destruction is mainly done by the enzyme monoamino oxidase. So to protect our 5-hydroxytryptamine by the attack of monoamino oxidase, what we need to do? We need to give protection to this 5-hydroxytryptamine. So what kind of protection means? We need to transfer this serotonin inside a vesicle. So for transferring this compound into the vesicle, we want a transporter, and the name of this transporter is VMAT2, that is vesicle monoamine transporter 2. Via this transporter, the serotonin compound is moved inside the vesicle. Okay, So this stars, you just assume this stars is nothing but your serotonin. Similar kind of transporter is also found in the platelets. So by this we got to know that platelets is also the area where storage of serotonin is been taking place. May not synthesis, but storage of serotonin takes place inside the platelets. Okay, so this is about the storage. Okay, so why we need to store this serotonin inside the vesicle? Because to protect it from the monoamino oxidase, and for storage we require a transporter, that is VMAT2 transporter. And this VMAT2 is not only present inside your the neuronal vesicle, but it is also present inside the platelets also. So serotonin is not only stored inside the vesicles of the neuron, but it is also present inside the platelets. Okay, so this is regarding the storage. Next we'll check out the release. So for release, it takes place in exactly same manner how other neurotransmitters are being released. So suppose this serotogenic neuron is under resting condition. So at resting condition, this neuron is having a resting membrane potential of minus 70 millivolt. Now suppose threshold potential is minus 60 millivolt, and little bit this neuron is getting stimulated, so that resting membrane potential has been moved to threshold potential. And once threshold potential is been attained, then threshold potential sensitive voltage gated sodium channel opens up, causing massive influx of sodium ion, so that the negative polarity is moved to positive polarity. So from minus 60 millivolt, the polarity has been changed to plus 10 millivolt. So you can say there is changes in the charges. This condition is known as depolarization. And once depolarization occurs, this voltage gated sodium channel will be closed, and two important channel, that is calcium channel and potassium channel, will be opened up. Via calcium channel, calcium ion moves inside, and via potassium channel, potassium ion moves outside. So for a brief duration of time, positive charges move inside and positive charges moves outside. So the net effect is, okay, we are watching the influx of calcium ion because there is a role of calcium ion. I am not showing outflux of potassium ion. Potassium ion is also moving outside, but I am not showing over here. Okay, so for a brief duration of time, calcium ion is moving outside and potassium ion is moving outside. So for this reason there is a plateau attained. But after some times, this this calcium channel also closes off, and only potassium channel is opens up. It's remained open, because of which outflux of potassium ion takes place, loss of cation, because of which the polarity moves back to minus 70 millivolt, and this condition is known as repolarization. So we know action potential, which is nothing but depolarization followed by repolarization. But when this action potential was been taking place, we saw few calcium ion moved inside. Influx of calcium ion took place. So what this calcium ion will do? This calcium ion is responsible for the fusion of the vesicular membrane protein with the axonal membrane protein. Okay, both the membrane fuses up and it opens up, causing exocytosis. So this is how release of serotonin will be taking place. Okay, so calcium ion has got a great role to be played over here. This calcium ion causes fusion of the vesicular membrane with the axonal membrane, and because of which serotonin will be removed, or it is be released by exocytosis. So this is about the release. Now after getting released, what will happen? We know serotonin will bind with its receptor to produce action. But suppose after getting released, still it has not acted upon its receptor, and it is just released out and it has not produced any kind of action. So what happened when it is not approaching to its receptor? We have got another mechanism. There is a transporter present on the nerve ending of the serotogenic neuron only, and this transporter is known as serotonin transporter. So what this serotonin transporter will do? It will transport the serotonin back inside its neuron. So this phenomena is known as reuptake. Means the role of this serotogenic neuron is not only to synthesize, store and release, and its work is done. No, When serotonin has not acted upon its receptor, then the role of this neuron, this serotogenic neuron, is to again reuptake this serotonin inside its neuron, and this condition is known as reuptake. And after getting reuptake, again this via this VMAT transporter, it is moved inside the vesicle so as to protect the serotonin from the monoamino oxidase enzyme. So this is about the synthesis, storage, release, destruction and reuptake of this serotonin.